In the frozen silence of space, 1 million miles from everything you've ever known, a golden mirror floats in darkness. It's enormous, larger than a tennis court, composed of 18 perfect hexagons, coated with a layer of gold so thin, it's measured in atoms. This isn't just any telescope. This is humanity's most ambitious eye on the cosmos. The James Webb Space Telescope isn't satisfied merely detecting the tiny dimming of starlight as planets pass by. It breaks down the remaining light into a spectroma-stretched rainbow, revealing exactly which wavelengths were absorbed by the planet's atmosphere. And hidden within the spectrum lie secrets. Every molecule absorbs light in its own unique fingerprint. This is how we read the chemical composition of worlds we've never visited, analyzing air that flows over alien landscapes, the deep blue of our oceans, the brilliant white of our clouds, the greens and browns of our continents. But what makes Earth truly extraordinary isn't its beauty, it's what happens on its surface. Just beneath our feet, life an explosion of life with such insane diversity that after 4 billion years of evolution, we still haven't cataloged all the species sharing this planet with us. For Earth 3.0, the transmission spectrum is remarkably rich. It shows dozens of clearly identifiable absorption lines corresponding to at least 7 distinct chemical compounds. This level of atmospheric complexity is something we've never observed on any other exoplanet. Look around the room you're in. The walls, the furniture, the objects all built by human hands. Primates who, just 100,000 years ago, lived in caves and chipped stone tools. Look at your hands. These hands were shaped by 4 billion years of evolution. The atoms that composed them were forged in the hearts of dead stars. Stars were too distant, the universe too vast, our instruments too primitive. But something changed, and that change has a name. The James Webb Space Telescope isn't just a scientific instrument. It's the result of 30 years of hard work, repeated failures, budget overruns, political battles, and the stubborn determination of thousands of engineers and scientists who refused to accept that some questions were too big to answer. Hubble could see only visible light, the kind our eyes perceive. But the universe primarily speaks in a language our eyes don't understand: infrared, heat. Imagine being in a forest at night without a flashlight. You'd see nothing, but with heat-sensitive eyes, the entire forest would illuminate. You'd see every animal, every insect, every leaf gently radiating heat into the darkness. The universe works the same way. Newborn stars, still wrapped in their cocoons of gas and dust, shine in infrared witch shapes. The oldest, most distant galaxies, whose light has been stretched by space's expansion over billions of years, are only visible in infrared. The primary mirror was too large for a rocket's payload fairing. Engineers cut it into 18 hexagonal segments, each coated with that famous atomic thin layer of gold, excellent for reflecting infrared. These segments had to unfold in space, then align with each other with nanometer precision. The instruments had to cool gradually. Every step had to work the first time. There was no plan B, no rescue mission possible 1 million miles from Earth, and every step worked perfectly. The spectrum was different, immediately, visibly different. No complex statistical analysis was needed to see something remarkable was happening. The absorption lines were numerous, deep, complex. Her first instinct was to check her calculations. Maybe Shed selected the wrong star. Perhaps the data was contaminated by interference. She rechecked everything twice, 3 times. The data was correct. She contacted a colleague, then another. Within hours, an entire team was hunched over the same data, eyes wide, verifying and re-verifying what each saw independently. That night, no one went home. The next morning, the institute director was informed. Secure communications were established with other observatories. Complimentary observations were urgently requested. The scientific machine, usually slow and deliberate, began turning at an unusual speed, as everyone understood what was at stake. This dizzying moment of discovering you're not alone. Carl Sagan had anticipated it. On February 14, 1990, as Voyager 1 drifted away from our solar system, Sagan convinced NASA to turn the probe's camera back toward Earth. The resulting image, known as the pale blue dot, showed our planet as a tiny pixel in a sunbeamless than a point, thus suspended in a ray of light.
But today, thanks to James Webb, we can add something to Sagan's reflection. In another point of light, 130 light-years from this sunbeam, someone else might exist. Someone who may have taken their own photograph, turned their own instruments toward their world, and contemplated their own version of this pale blue dot. Not a clear message, not a modulated signal carrying obvious information, something much more subtle. An excess of radio radiation coming from the direction of that star at specific frequencies, with characteristics that don't match any known natural astrophysical source. Finding this same atmospheric imbalance on another planet 130 light-years from home is like discovering a campfire in a forest you thought was uninhabited. The smoke doesn't prove who lit the fire, but it proves someone did. Take a moment to absorb this. We've found a planet with an atmosphere so similar to ours that the data appears almost mirrored. 3 truths emerge from this journey. First, life appears to be a natural consequence of chemistry and physics under the right conditions. Second, consciousness might be a common outcome of complex biological systems given enough time. Third, we're living in a unique moment in our species' history moment when we may have found tangible evidence we're not alone. Not speculation, not probabilities. Data. Look at the night sky. Find that orange light among the stars. It probably won't be visible to the naked eye, but it's there. Breathe deeply, we're just beginning. This planet received a catalog name like all exoplanets, a technical, cold designation of letters and numbers. But in Research Institute hallways, among informal conversations between astrophysicists, it earned a nickname Earth 30, not Earth 20. The next breakthrough will come from new generations of ground-based telescopes, European ELT, the TMT, the GMT, whose 30-40-meter mirrors can analyze this planet's atmosphere with resolution 10 times superior to James Webb. It may come from confirmation or refutation of the interstellar anomaly. The truth is, we're living at a crucial moment when science stands at the edge of a precipice, looking into the abyss. Our atmosphere speaks of us. It tells our story to anyone with a sensitive enough instrument to hear it. It says life exists here. It says this life is complex, diverse, abundant. But it also says something else. It says carbon dioxide concentrations are rapidly increasing. And this planet has it. Now consider this interstellar anomaly signal detected between the planet and us. If we speculate, even as an intellectual exercise, that this might be an artificial object transiting interstellar space, our own civilization's history offers a frame of reference, however inadequate, for imagining what a more advanced civilization might build. We're finally beginning to understand. A universe where life might be everywhere, where intelligence whispers in infrared, where civilizations rise, grow, and gaze at stars with the same emotion we feel right now. Somewhere 130 light-years from here, beneath a sky illuminated by an orange star, something exists, something alive, something conscious, something that might know we're here. And we've finally begun to know they're there too. This is the beginning of a story that could last millions of years, a story we won't finish, but one we have the immense privilege of writing the first lines for. The James Webb Space Telescope didn't just discover a planet, it opened a door we can never close again. On the other side of that door lies a universe we're only beginning to comprehend.